Okay, so after the last class, if you have any doubt, you can ask. Basically, the theory portion from CAM module already we have covered. Okay, so that portion is already done. So if you have any doubt with those, like how we have to do or draw this particular displacement diagram, velocity diagram, and acceleration diagram for different cases. Okay, so if you have any doubt, okay, so you can ask. Okay, so after that, today we'll see how to basically draw the cam profile, or you can say the design of cam profile, how we have to do. Okay, what we mean by kinematic inversion. So those things today we are going to discuss, and after that we'll solve some numerical with respect to designing of cam profiles. And so for that, as I have already discussed in the last class, okay, I told you to be ready with your page, okay, page, pen, pencil, etc., and other geometrical instruments, so that you can draw that cam profile along with me. Then it will be kind of you. It will be helpful for you. Okay, so all of you, if you don't have access to a page, pen, paper, and other geometrical instruments, just I'm giving you 2 minutes. So within that, you just do that. Okay, so be ready with that, so that if, otherwise what will happen if I'll just show how to draw and like that. Okay, and if you don't follow, then it will be useless. So it's better you practice alongside me. Okay. Okay, so I hope my screen is visible.
Yes, sir.
Okay,
Yes,
so
sir.
all of you are ready with. Okay, so all of you are, I believe, are ready with your record instruments, right? Okay, so in the last classes, basically, we have already gone through how to draw the displacement diagram, velocity diagram, and acceleration diagram for different motion, standard motion of the your follower. Okay, so there we have discussed about the uniform velocity case, and we have discussed about SHM, and also we have discussed about uniform acceleration and retardation case, and also at the last we have discussed in the last class about the cycloidal motion profile. Okay, so there we have gone through the various standard expression for getting the displacement, velocity, acceleration, etc. So those values, those expressions directly you can utilize if in the question, if it is asked to find out, suppose the maximum velocity or suppose the maximum acceleration, etc. So, but be cautious with respect to whether they are asking about the maximum velocity or acceleration, etc. in the, whether it's in the ascent stroke or in the descent stroke, etc. Okay. So, what do you mean by ascent stroke? What happens in the ascent stroke or the outstroke? You can tell me. Who can tell me what happens in the ascent stroke? No. And what about descent stroke? What happens in the descent stroke? Rehan, Hermiki, Emil, who can tell me? What do you mean by ascent stroke, descent stroke, dual stroke?
Resistance stroke goes up, I think.
Goes up means follower goes up or the cam goes up or what?
The follower.
The follower moves up, okay? Follower moves up. Okay, the descent follower moves up. Okay, dual, there is no motion or displacement of that follower, but there is movement of the cam. Okay, So now today we are going to see how to draw the camp or how to construct a camp profile or the layout of camp profile, how we have to construct. Okay, so basically
Yes, sir.
about this construction of camp profile in some of the classes already, some of the portion already we have covered. So now it will be kind of continuation of that. Okay, so this camp profile is generally constructed on the principle of, there is one principle known as the kinematic inversion principle. So that is the basis of construction of your cam profile. Okay, so what we do in this kinematic inversion consideration, okay, so we consider that the cam is stationary and the follower is rotating about it in the opposite direction of the cam rotation. Okay, this is what is the assumption. Okay, this is the kinematic inversion assumption principle that we follow here for constructing the cam profile. Okay, and what we follow, we consider, even though actually the cam is rotating, we consider that to be stationary, that is the cam, and we consider as if the follower is rotating about it, but in the opposite direction of the cam profile, cam rotation. Okay, so now if that is happening, so how we can this cam profile of you, and all of you understand that profile of the cam means nothing but you can say the design or the actual working surface of that cam, or you can say the actual look of that cam. Okay, so now if let's consider this is the cam, okay, which rotates, and this is the follower which is reciprocating here. Okay, but for construction purpose or cam profile construction purpose, we consider as if the follower is rotating around the cam. Previously, actual cam direction of motion was here. We'll consider follower motion to be, we'll consider this to be stationary. Okay, there is no motion. We'll consider like that, and we'll consider as if the follower is rotating but in the opposite direction. Okay, cam rotation is actually here. Follower rotation we'll consider in the opposite direction to the cam. Then what will happen if we so see actual working for proper working of the cam and follower, so we know that there has to be constant contact between the cam and the follower. Okay, and that is there, always there. Okay, if there is no contact between the cam and follower, actually follower will not get any motion from the cam. Okay, that's why constant contact is always desired, and that has to be there, and it is there if it is actually working. Okay, so now if that is happening, and we are assuming as if the cam is follower is rotating about the cam, then what will happen for each, and just like in the displacement diagram what we do. Okay, in the displacement diagram, if you recall, I'll just take some space. Okay, we have considered theta along x-axis and the displacement y along y-axis. Okay, that means it shows that basically at different theta what is the lift of the follower, that, and from that position, from if this is the curve, okay, so from this knowledge, what we'll know, we'll get the knowledge about actually the position of that particular follower. Okay, that means if you consider like that, then depending on the leaf, so at a particular location or particular cam angular movement, what is the leaf of this particular follower, that we will know. Okay, and if that is translated in the backward, okay, if you do for reverse engineering kind of thing, okay, in the reverse direction, if you just follow, then it is like we'll get the location of this particular contact point. Now we know that this cam and this follower is in constant contact. That means at this particular position, this itself is the working surface of the cam. Okay, and this logic if we extend throughout this, like for this complete revolution, okay, 360-degree, then we'll end up getting the idea of the profile of the cam. Okay, so this is what we do here. Okay, so now the constant contact will be there, and based on that actually we are going to get that particular thing. Okay, so now in general, if you're thinking of a reciprocating follower, then what we do, what are the steps involved? First step is you have to draw the displacement diagram of that particular follower according to the given follower motion. Okay, so according to the given follower motion means just like some of the different standard motion we have studied, like uniform velocity case we have seen, SHM we have seen, the cycloidal motion case we have seen, we have also seen about the uniform acceleration and retardation case. Okay, so that way in the question it will be said, okay, suppose this particular stroke, if it is upstroke or like return stroke or whatever be the stroke, okay, this is taking place, suppose let's consider in SHM motion. So in that case you have to, taking that whatever is the value etc that is given, you have to draw the proper displacement diagram of that follower according to the follower motion. You cannot suppose if it is SHM motion, it is happening with SHM motion, suppose that particular stroke, you cannot draw the displacement diagram considering some other type of motion. Okay, then it will be wrong. Okay, so now this one important thing is there, the scale of the displacement interval, actually it is not going to affect the cam profile. Okay, but if you consider the follower displacement, okay, follower displacement scale, okay, that is going to give you some different look, okay, of that, or you can say that it will basically affect the size, okay, and that cam profile will affect. Okay, so now first thing, displacement diagram you have to draw, and next step is basically we are going to construct the cam profile. Okay, and for that we have to draw the prime circle of the cam, and if it is a roller type of follower, then the value of the prime circle, the radius of the prime circle, okay, it will be different. And if it is a knife edge type of follower or a mushroom type of follower that we are talking about, then it will be different. Now in case of knife edge and mushroom type follower, we already know directly the contact point, okay, the prime circle will be similar here. Okay, so basically the contact is made here. Okay, the tracing point is exactly at the knife edge in case of knife edge follower. Okay, but if it is a roller follower that we are talking about, then we know it is at the center of the roller. Okay, and the roller, this particular portion is income. Okay, so that's why if we are talking about mushroom follower or knife edge type of follower, then directly prime circle will take by taking the radius directly the roller RC, that is a cam minimum radius. And if it is roller follower, then the addition of the roller radius has to be considered. Okay, so that is the next step. And after that we have to divide the prime circle into certain segments. Okay, if it is radial follower, then once again radial follower and offset follower case will come. Radial follower means, now if we look at this particular figure, this one, can you tell me whether it's a radial type of command follower arrangement or a offset type? There is some eccentricity as you can see here. So this is offset type. Okay, had it been radial type, then the axis of follower motion will pass through the axis of motion of this particular cap. Okay, then it will be inline or radial. Okay, now once again, if it is radial follower, you have to divide the circle from the vertical position, indicating the different angles of ascent, dwell, descent, etc., and in the opposite direction of the cam profile. Okay, if it is a offset follower that we are talking about, we have to draw another circle with radius equal to the offset value. Okay, and assume the initial position on the prime circle where the tangent of the this thing you will see once we solve the problems. Okay, don't have to just go through that. Okay, and after that, once again we have to divide uh, ascend descend it to some equal number of angular parts that you do in the displacement diagram. Okay, so that means basically the displacement diagram has got so many things to do with drawing a proper cam profile. Okay, that's why the first step, that is the drawing the displacement diagram for this case as per scale. Okay, scale is very important. Considering proper scale and maintaining the scale is very important. As per scale is very important. Okay, so after the displacement diagram, taking some values from the displacement diagram, we are going to draw the cam profile. That's why first step itself is one of the important step. If you make mistake in the first step, then it will be difficult. Okay, that's why you should be careful in the displacement diagram, and you should know how basically that particular displacement diagram should be drawn for different motion profile. Okay, then once again, like for knife edge follower, like how to draw the curve, for roller follower how to draw the curve, those things are listed here. I have written here, but you can go through it. But it will be useful if you solve the problems, and then automatically you will understand how to do that. Okay, here I have written it down. Okay, up to this was any confusion?
No, sir.
Okay, thank you. Yes, yes, do ask the question. Yes, you can ask the question. Okay, seems no. Okay. So now, see one important thing, just like I have already discussed, the shape of the cam profile is generally obtained from the displacement diagram of the follower. Okay. So what will be the first step then? So the first step in constructing the cam profile is to draw the displacement diagram according to the desired motion of the follower, and proper scale is very important. Okay. Now we go for the reversing the actual condition, that is the kinematic inversion case. Okay, now we consider the kinematic inversion. Okay, and now the kinematic inversion is already I have discussed. Okay, assumption of those particular motion, etc. Okay, and the profile of the contact surface of the follower with the cam for the successive position of the follower actually gives you the actual profile of the cam. Just like we have already discussed, we know it's still always constant contact. So now if we have different divisions for it, okay, at different intervals, I can actually get the idea about where is the position of that particular follower at a particular condition of your cam. Okay, and from there I can get the idea about the position of that particular cam and the cam profile, that is the actual working surface. Okay, so this theory part basically is over. So if you have any question, you can ask, otherwise we'll go for solving a problem. And you all of you take out your paste, pencil, all those other geometrical instruments. You practice alongside me, then it will be useful. Is that clear? All of you are ready?
Yes, sir.
What about others?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, then we'll start. Okay, we'll start. Okay, so what the problem statement says, you have to draw the profile of a cam which is operating a knife edge follower. So see, once you go through the problem statement, you just try to find out the point of importance. Okay, important points. Okay, and note them. So this you have to do a profile of the cam operating a knife edge follower. This is important. Right? Okay, operating a knife edge follower having a lift of 30 mm. This another very important value. The cam raises the follower with acid step. Raises the follower means which stroke we are talking about? Right stroke. Okay, with acid stem. That means right stroke is acid stem. For 150 degree of the rotation, 150 degree of the rotation means what is the right stroke angle? First we'll just go through the whole question, then I'll try to reduce all those things. Okay, so draw the profile of a cam operating a knife edge follower having a lift of 30 mm. The cam raises the follower with SHM for 150 degree of the rotation, followed by a period of dwell for 60 degree. The follower then descends for the next 100 degree rotation of the cam with uniform velocity, again followed by a dwell period. Okay, so the cam rotates at a uniform velocity of 120 rpm and has a least radius of 20 millimeter. What will be the maximum velocity and acceleration of the follower during the lift off and the return? Okay, so now during the now what is our thing? Okay, we need to take out the important point from here. That means what kind of follower that we are talking about, what kind of motion of the follower. Okay, what is the angle, etc., that is given. Okay, what is the rotational value of the cam. Okay, all those things whichever is given, that we need to reduce. Okay, so first and foremost, what we have obtained, draw the profile of a cam operating a knife edge follower. This is important. That means it is a knife edge follower, because depending on whether it's a knife edge follower or roller follower, the way you have to draw the cam profile will be somewhat different. Okay, and then what is given, having a lift of 30 mm. So H lift can denote with H or X, that is up to you. H equal to, given that I write down. Okay, so given follower type is knife edge follower. Next, the lift is 30 mm. The cam raises the follower with SHM, okay, for 150 degree of the rotation. So theta A, or here we are using phi A, that is up to you. Okay, you can use theta A, no problem. Okay, whatever nomenclature you use, just denote them. Okay, use mention them. Okay, so suppose theta A, that is the ascent stroke angle, is given as how much? 150 degree. Okay, 150 degree. And so that you don't make mistake in the next step, here itself in bracket you write it down what kind of motion is there. So it raises the follower with SHM. So SHM motion for the SN stroke. Okay, followed by a period of dwell for 60 degree. That means there is one dwell period. Okay, first delta. Okay, delta 1 del 1 equal to what's the angle? 60 degree. Okay, so during dwell what kind of motion is there in the follower? Is there any motion in the of the follower? There is no motion for that case. Okay, and after that what happens? The follower descends for next 100-degree rotation of the cam with uniform velocity. Okay, so that means theta d is given. What's the angle? What's the value? 100 degree. And be careful, be mindful here. So now theta a and theta d for ascent stroke as well as descent stroke, both the types of motion that the follower is exhibiting are different. Okay, so now here it is with uniform velocity. Okay, uniform velocity. Okay, and again followed by a dual period. So that means second delta is there, delta 2. Now how to find out this value is not given. How to find it out? We know that the total one complete rotation will consist of this 360 degree. Okay, so for the other three strokes, we already have the values. Okay, so if I just eliminate them, then we are going to get the value for delta 2, right? So by doing that, we get this to be 50 degree. Okay, so after that, what is given? The cam rotates at a uniform velocity of 120 rpm. So n is given 120 rpm, and it has a least radius of 20 mm. So now from that least radius indication, basically we get the idea about the base circle and the size of that particular, that is the minimum one. Okay, so RC, radius of the circle, is 20 mm. So these are the given data, and you need to find out the maximum velocity V max and your acceleration. You can either denote it A or F, that is up to you. F max during both the strokes in theta A, and because it is said no, during lift and during return. That means ascent stroke, lift mean ascent stroke in theta A and theta D. Okay, so now these are the thing. These are given and you need to find it out. This one you need to find it out. Okay, is there any confusion up to this much? How we have extracted the data? No? Okay, that didn't follow. Okay, so now here comes the main part. Okay, now first step is we'll have two basic steps. Okay, first is you have to draw the displacement diagram. Okay, displacement diagram is important. Displacement diagram for that particular case. Okay, considering whatever is the type of motion that is given. Okay, so second step, construct the cam profile. Okay, so these are the main thing. Okay, so now for constructing second step, okay, for going to construct the cam profile, you cannot directly jump to second step. Okay, first you have to follow this, next only this. Okay, this is the first step, this is the second step. You cannot directly go here. Okay, and this has got relation with this. Okay, because you are going to take data from here, take data to properly draw the cam profile from the displacement diagram. That's why drawing the displacement diagram is very important, and you have to maintain proper scale. Scale has to be maintained. You have to mention also. Okay, it's not like you have maintained the scale and you have not mentioned what scale you have utilizing. Don't write plastic scale, those scale kind of thing. Okay, so properly you just mention along x-axis how much you have considered. Okay, what is the conversion factor? Along y-axis, what is your conversion factor? That is basically gives you the idea about the scale. Okay, and from there in the next one you are going to utilize that value. Okay, so that is how we are going to do. So now for doing the displacement diagram, what we consider along x-axis and what we consider along y-axis? Who can tell me? Along x we consider cam angular displacement theta. Okay, and along y, that is the lift, okay, ultimately the displacement of the follower. Okay, so now what we are interested in, we are interested in getting that particular case. Okay, so for that we already have the maximum lift. Okay, h is already given. Okay, and we have the theta a, then the delta 1, theta d, and delta 2, delta 2. So these values also we already have. Okay, so now considering these values as per proper scale, we are going to draw the displacement diagram. Okay, so for that, depending on suppose what kind of values are there, you just have to judicially select your scale, because 150-degree, 60-degree, 100-degree, 50-degree, these kind of values are get there. So you can take like 30-degree along x-axis, you can consider as if like 25-degree or 30-degree to be 1 centimeter. Okay, so that way you have to convert. Suppose if suppose 30-degree is 1 centimeter, then theta a, for theta a, how much you have to draw? That is 150-degree. So 150 by 30, that is, it will be 5 centimeter, like this. Okay, this is the scale that you have to indicate. Okay, understood? So what we'll do now, we'll along the x-axis, the horizontal line you'll draw, and vertical line of there, and you have to, what you have to do, first theta a is with what? Theta a with SHM, and theta d with uniform velocity. Okay, so for both the theta a and theta d, the curves will be different. Okay, so sometimes it may so happen that for both the cases theta a and theta d, both the things are happening with SHM, then there is no problem. Okay, so directly you can utilize the same type of motion. Okay, and here you have to be careful. Okay, so now after doing the x, okay, then as per your scale, whatever you have considered, then you have to mark it. Let's consider 150-degree. Okay, that has to be like 30-degree. I am considering to be 1 centimeter, so 150-degree will be 150 by 30, okay, that is 5 centimeter. So we have to mark all this in the horizontal line. Okay, in the 5 centimeter I'll just mark. Okay, and after that, next one is delta 1, that is the, this is theta 1 SN stroke. After that, del 1, that is the first dwell. Okay, first dwell is given as how much? 60-degree. So 60-degree will be how much then? How much centimeter? 30-degree I have considered as 1 centimeter. So 60-degree which we can go for 2 centimeter. Okay, so at 2 centimeter from here you'll mark here. Okay, and from here, for according to that particular scale, okay, 100-degree, it will be like 100 by 30. Okay, whatever be the 3 point something it will come. Okay, here you will mark it. Okay, and once again, depending on what is the leaf that is there, okay, along y-axis also you'll consider it judiciously, and as per the given value, okay, you'll, okay, so after that you will complete this particular, you'll just follow the way you have to do for displacement, drawing the displacement diagram, and okay, and this theta a, here it ends. Okay, we'll complete this particular rectangle. For delta 1, first delta will complete here. Okay, and as there is, as I have already discussed in last class, okay, if there is a dual at the end, you may or may not show it. If you want, you can so extend like this, and as per scale you can draw, no problem. Okay, next delta, that is, there is another dual. Okay, so you may or may not show, that is up to you. Okay, after this much, any confusion, anyone? Let me know if there is any confusion. Are you following me, all of you?
Yes.
Yes, sir.
Okay, so you're trying. You have also you're also drawing alongside me, right? At least rough drawing. At least you can have. Okay. Okay. Thank you.
Yes.
Okay. So after this one, I hope it's clear. So now SN stroke is with what motion? SHM. Okay. So now for drawing the SHM. Okay. How to do it? If you recall, so this particular leaf value we are going to consider as the diameter, and we are going to draw the semicircle here. Okay, Now we need to divide it into some equally spaced even number of parts. Let's consider we are making 6 division. So 6 division we are making this using your protector. You have to equally divide them. You cannot like arbitrarily divide it. Okay, 180 degree divided by 6 you do, and this 30 30 30 30 like that. You have to always name those division 1 2 3 4 5 6 like that. Okay, this starts from 0. Now as we have made 6 division here, now in this ascent stroke also we need to make the similar number of division. That means the same number of division. That means the 6 division only, and these are equally spaced. You cannot arbitrarily draw it. So it was 5 centimeter as per scale. Okay, whatever be the value. So you have to now make 6 equally spaced division. Had it been 6 centimeter, then if it is 6 division I have to make, then I'll be making like 1 centimeter each. Okay, now depending on whatever is the value as per your scale, you have to make 6 equally spaced division. So you'll mark here, suppose 1 2 3 4 5 6. Okay, and these are equal space mark. Okay, and after that you will draw the vertical lines here. We'll divide it. Okay, this is for only ascent. Done? Up to this much, all of you have understood?
Yes,
Okay.
sir.
Okay. So
Yes,
after
sir.
that, what you have to do? So from those division that you have made in the semicircle, okay, 1, 2, 3, 4, 5, 6, okay, you draw horizontal lines parallel to the x-axis. Okay, like this. And as we are only interested in the SN stroke now, you don't have to extend. You don't have to extend up to this much. Okay. Had it been like both the strokes, theta A and theta D with theta D, that is the SN stroke and descent stroke with same type of motion, that is the SHM, then you could have extended up to this much, these divisions up to this much. Then it will not be any problem. But right now it is not needed because SHM is only there for the SN stroke only. Okay, that's why in the SN stroke only we are interested. So now from the trace you can either draw this horizontal line throughout the SN stroke, that is your choice. Okay, or what you can do to make it somewhat clear, okay, we know that to locate those points we are interested in for the first division. Okay, so first horizontal line we are interested in getting the intersecting point with the first vertical line. Similarly for the second horizontal line we are interested in getting the intersecting point with the second horizontal vertical line, and so on. Okay, so that's why I have extended up to this, from to the horizontal line extended up to the second vertical line. Okay, so this is the point of intersection. Similarly from third we have extended up to the third vertical line, so here is the image, this is the point of interest. Fourth we have extended up to fourth, this is the point. Similar is the fifth up to this much we'll get, and sixth is this, sixth division is this, and here it is 6 dash. Okay, so now name those points. Okay, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and 6 dash. Okay, so these are the points, and from 0 point division, okay, we'll just draw a, will curve, smooth curve passing through those points. Okay, so now for theta a this portion is done. Okay, so theta a is done. So now always give nomenclature to those divisions. Okay, 1 2 3 4 up to 6. Okay, up to this much I hope it's clear. So after that, once it is done, SN stroke is done, then we have the 12.
That is 6 dash to 6 dash is dual, no, sir.
Hmm? Ah, 6 to, yes, this much is 12. After that, we are coming for 12. Okay, already this division already we have made the. Okay, just wait. If I get some other color, I'll use some other color. Okay, I think there is no color option. Okay, whatever. Okay, so now we are talking about this 12. Okay, so from here to here, this is the 12, right? Now, in this case, what happens? Is there any motion of that particular follower, or is there any displacement of the follower during duel? There is no displacement. And now, previous position of this flipped follower is here. Okay. Now, what you will do throughout this, you don't even have to make any division here. Okay. And this you just darken here. Okay. Throughout the duel period, it will remain here. Okay. So duel is done. After that, we have got descent. Okay, so now for the descent stroke, once again you just divide it into some equally spaced even number of division. You can go for 6, 8, etc. That's up to you. Okay, so we have made 6 divisions. So all those vertical lines you have to draw this vertical lines. Sorry, these diagrams, drawing diagram here in the laptop is difficult. Okay, so and do the division names. Okay, 7, 8, 9, etc. up to 12. Okay, and this is now with, is it with SHM or something else? Is it with SHM or something else? What type of motion is there? So this is with uniform motion. Okay, that's why this is like this. Okay, and wherever they are meeting, so these are the point of interest. Okay, understood? So these are 7 days, 8 days, 9 days, 10 days, 11 days, and 12 days, like this. Okay, so this is how you have to draw the displacement diagram. You keep the name of the figure, always write the name of the figure, caption of the figure should be there. Okay, figure 1, this is the displacement diagram. Okay, so first step is over. Now considering proper scale here, why it is important? Because see, these lines, whatever up to the curve you get, okay, so these heights, actually this height, this height, this height, etc., etc., they actually give you the indication about at this particular location, that is 1, 2, 3, 4, 5, 6. Okay, what is the lift of the follower? Okay, so that is the idea it gives you. And using this idea, what we get actually the size of the shape of that particular shape, as well as size of that particular cube. Okay, so why? Because we know there is a minimum size, minimum, that base circle is there. Okay, that is the given by minimum radius of this particular cam. Okay, if this is the cam, okay, this is the center of it. Okay, and then from here, that means at a particular cam angle, okay, how much extension is there? Okay, whether it is this much extension, this much extension, this much extension, or like that. This idea is given by this leaf fellows. Okay, so that means at this particular angle, this much is the leaf. This much is the leaf means this is the position of the follower. That means if less leaf, okay, somewhere else is the follower position. Okay, that is the working surface. How it will look, it will be given by that. Okay, so for today we'll stop here in the displacement diagram. In the next class, what we'll do, using this displacement value from the displacement diagram, we'll see how to draw the cam profile for this particular case. Particular case means we are having a knife edge follower. Okay, knife edge follower. For knife edge follower, we know the trace point lies at the knife edge itself. Okay, so in that case, how to draw? Similarly, in the next class, maybe. So can anyone tell me it's a what type of cam and follower arrangement, whether it's a radial or in offset type? So in the question, nothing is been mentioned. That's why you just consider this to be inline or radial. Okay, then your problem will be somewhat easier. Okay, if you from yourself, if you consider this to be offset, then it will be somewhat difficult, and you have also have to consider the offset value. You have to assume the offset value judiciously. So better you just consider this to be your radial or inline type of flow. Okay, so understood. So with this, will stop here for today. So if you have any question, you can ask. Any confusion? So all of you have understood or not? Just let me know. I hope to be yes. Okay. So what you do, if you have not used a proper scale today, so this problem you start with this at least the displacement diagram up to the displacement diagram you make it complete. Okay, completely you just draw it using proper scale and all. Okay, and using proper geometrical instrument. Okay, so this will stop here. So I'll take the attendance now. Respond to your name calls. Nilutpal, Nilutpal, absent. Shankar, Shankar, absent. Arsisman,
Present, sir.
Rehan,
Present, sir.
Partha,
Present, sir.
Rishikesh Basumatari,
Present, sir.
Chermiki,
Present, sir.
Nohosol, Nohosol,
Yes, sir.
Theza,
Present, sir.
Present, sir.
Theza,
Present, sir.
okay. Rishikesh Nath,
Yes, sir.
and Emil.
Yes, sir.
Okay, so thank you everyone for joining. We'll meet in the next class.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thanks, sir.
Yes, sir.